10101 more a non-overlap. Non-overlap in the sense, for example, what if I receive sequence like this? This is my input sequence and my output will be 1 whenever I detect this complete sequence 10101. Till then my output will be 0. Whenever we detect this complete sequence, then output will be 1. So first we received only 1 bit, so output will be 0. Here also 0, 0, 0. Here we detected this complete sequence 1. And if we observe, for next 10101 sequence, input should start with 1, but here we have 0. So it will not match, and it will start from here 0, 0, again 0, 0, 0. Here we are detecting complete sequence, so it will be 1. Previously in overlap, if we observe this sequence 101, 01, here also we can make one complete sequence and our output can be 1. But here this 101 is already used for this sequence, so we can't use these 3 input bits for these 2. It will be overlapping. In question they asked non-overlap, so that we should not overlap this 101. Like the input bit which are included in one sequence cannot be used for another input sequence. That is non-overlap. Initially we will be in ideal state, and whenever we apply reset we will be in this state. So our required sequence is 10101. What if we receive 1 as first bit? With this 1 we can make this sequence right. 1 bit is matching for this sequence, so we will go to 1 bit match state where we don't have that. Ideal state will be considered as 0 bit match state, and we want 1 bit match state where we don't have that state, so we need to take one new state. Name can be given as your wish. This will be considered as 1 bit match state. What if instead of this 1 if we receive 0? These are bits, right? Bits can only be 1 or 0. We should check all the possible cases. First, what if we receive 1? We will go to next state as it is 1 bit match state. What instead of this 1 if we receive 0? With this 0 we can't make this sequence because this sequence is starting with 1, whereas our first bit received is 0. So it will be 0 bit match state where we already have this state, so we will be in this state itself. For every state we should check transition for input bit 1 and input bit 0. For this state we already took input bit 0, it will be in same state. For input bit 1 it will go to next state, and for this state we need to check. Our required is 10101. We are already in 1 bit match state, that is we already received 1, and we are checking for second bit. What if my second bit received is 0 only? With this 10 we can make this sequence right, 10101. So it will go to 2 bit match state where we don't have that state, so we will take to next state. And instead of this 0, what if we receive 1? 1 and 1. Here we are checking for 2 bits, so here also we should check for 2 bits from MSB bit side. MSB is this, LSB is this. We should check from MSB side. 1 and 1 are not matching with 1, 0. So we will strike off the MSB bit from our received bits, and we should check with the latest bit. This latest bit 1 is matching with this bit. 1 and 1 are matching. So we will be in 1 bit match state. Here we are here, instead of this 0, if we receive 1, we will be in 1 bit match state where we will be in same state. For this state, 0 transition is done and 1 transition is done. Now we should come for this state. Required is 10101 and received is, we are in this state, that is we already received 1 and 0. What if my next bit is 0? What if we receive 0 as next input? 100. Here we are checking for 3 bits, so here also we should check for first 3 bits. 101 is not matching with 100, so we will strike out MSB bit and check the latest 2 bits. 00 is not matching with 10, so we will strike out this 0 and we will check latest bit. 0 is not matching with 1, so we will strike off this also. This will be 0 bit match state. This we will consider as 2 bit match state, and we are here. If we receive 0, we will go to 0 bit match state where we already have this state, so we will go here. Instead of this 0, what if we receive 1? 101, 101. 3 bits are matching. So we'll go to 3-bit match state. Where we don't have that state, we'll take one more new state. This will be 3-bit match state. For this state, 0-bit transition is done and 1-bit transition is done. Now we should go to this state. Our required input sequence is 1 0 1 0 1. And what we received is, if we are in this state, that is we already received 1 0 1 as input. And what if I receive next input as 0 1 0 1 0 1 0 1 0? 4 bits are matching, and we'll go to 4-bit match state. Where we don't have that state, we'll take one more new state. If I receive 0, input will be 1 0 1 0. This will be 4-bit match state. And what if instead of this 0 we received 1? Instead of this 0, if we receive 1. For every state we need to check 0 transition as well as 1-bit transition. What if I receive 1 0 1 1 is not matching with 1 0 1 0? So we will strike out this MSB bit and check with the latest 3 bits. 0 1 1 is not matching with 1 0 1. So we will strike out this MSB bit and check these 2 latest bits. 1 1 is not matching with 1 0. So we will strike off this and check with the latest bit. 1 1 is matching with 1. So it will go to 1-bit match state where we already have this state. So from here, we are already in this state. Instead of this 0, if we receive 1, we'll go to 1-bit match state. That is, we'll go here. And for this state, 1-bit transition is done and 0-bit transition is done. Now we should come to this state. My required sequence is 1 0 1 0, and what we received is 1 0 1 0. We are already in this state. That is, we already received 1 0 1 0 bit. And what if my 5th bit is 0? Here 1 0 1 0 1 is not matching with 1 0 1 0 0. So we will strike out this MSB bit and check with these latest 4 bits. 0 1 0 0 is not matching with 1 0 1 0. Here how many bits we are considering? Here also we should consider those many number of bits from MSB side, that is from this side. 0 1 0 0 is not matching with 1 0 1 0. So we will strike out this. 1 0 0 is not matching with 1 0 1. We will strike off this. 0 0 is not matching with 1 0. We will strike off this. 0 is not matching with 1. We will strike off this. So this will be 0-bit match state. 0-bit match state in the sense this one. So we'll go here. For this state, 0 transition is done and we should check for 1-bit transition. What if we receive 1 instead of this 0? My required sequence is 1 0 1 0 1, and what we received is 1 0 1 0 1. 5 bits are matching, so our output will be 1. In Melee, we'll go to ideal state, but in Moray we should take new state, because in Moray output depends only on state. Here in every state you have only output 0, but whenever we detect this complete sequence, our output should be 1. So we can't go to ideal state. We should take one more new state. 1 with output 1. We should not leave any state ideally. That is, for this state also, we should take 0-bit transition and 1-bit transition. After detecting the sequence, what if my next bit is 1? We already received 1 0 1 0 1. This is our required sequence. And next bit, what if we receive 1? This is non-overlapping, right? So we can't use previous 1 0 1 0 1 bit. We should make new sequence with received bits. That is, these can't be used. So we can't use this. And with this new one, we can go to 1-bit match state, because if our next inputs are 1 0 1 0 1, we can make sequence, right? So this one can be used. This fresh one can be used. So we'll go to 1-bit match state. If it is 1. We are already in this state. Instead of this one, what if we receive 0? These 5 bits can't be used because it is non-overlapping. Any of the bits can't be used. With these 0, we can't make any sequence, right? Because 1 0 1 0 1 is starting with 1, whereas this bit is starting with 0. So we can't make any sequence. This will be 0 with the match state, where we already have that state.